Another kind of trick, as you'll see as we get through this question, is we're leaning towards, we're going to eventually get to F net equals MA, but sometimes the question doesn't give the A value. Sometimes we need to do a little bit of work to get the A value. This goes back to that good work we did in Unit 1, the kinematic stuff. Hopefully some of this comes back and starts to sound familiar or ring some bells in your memory. If I don't give you A, you may have to find it. If a shopping cart's pushed from rest, think back to that good work you did on that last test and on the quizzes. That means the V1 is 0. It gets to a speed of 3, so that means V2 is 3 meters per second. That's happening in a distance of 5. And in this case, I want to know the A value, so I can plug it into F net equals MA. It's been a while, but this is the scenario we don't care about T. So our equation is D equals V2 squared minus V1 squared all over 2A. Plugging in what I know, 5 equals 3 squared is 9, take away 0, all over 2A. A little bit of algebra, basically the A and the 5 are going to trade spots, so I'll let you do some lines in the middle if you like, but we're going to get 9 over 10, or 0.9 as the acceleration. Now it kind of turns into a question like that, the last bobsleigh question. We've got a backward force of friction. I want to know how hard you're pushing it, so we haven't done many of these, but how hard you're pushing is that F applied thing. We know what the FF is. We now know A, so we know MA. There's enough there that we can solve for F applied. I'm going to slide over here. Again, free body diagram to help us get started. Gravity straight down. It's mass times 9.8, but I don't really care about it. The normal is what we name that reactive force that's straight up, basically keeping it from falling through the floor. Oops. We're pushing it forward with F applied, but I don't know what that is. And then we're fighting friction, that's backwards. And I've got a number for that. Friction was equal to 50. When I set up F net equals MA, it's always going to be the bigger force minus the backward force. So in this case, the bigger force is F applied, that's our forward force. Friction is fighting us, so friction becomes a negative force, and that's equal to MA. We're going to see this kind of line over and over again when we deal with things sliding horizontally. The applied force has to overpower friction to make it move, so it's F applied minus FF equals MA. For this one, we don't know the F applied. The friction, just sliding back one more time, was 50. So I don't know for the F applied. Take away 50 equals the mass. Oops, I forgot the mass as well. The mass this time was 12 kilograms. And the A, we had to do that kinematics work. The A we just figured out was 0.9. So I don't know. Take away 50 equals 10.8. Basically what this is saying is that the F applied has to be 50 larger than the M times A value, 10.8 in this case. If we flip the 50 to the other side, we get F applied equals 10.8 plus 50, which is 60.8. The magic of Newton's second law in metric, that's a number that's going to be in newtons because it's a force.